Node.js or Node is an open source and cross-platform runtime environment for executing JavaScript code outside of a browser. Quite often we use Node to build backend services, also called APIs or application programming interfaces. These are the services that power our client applications, like a web app running inside of a web browser or a mobile app running on a mobile device. These client apps are simply what the user sees and interacts with. They're just the surface. They need to talk to some services sitting on the server or in the cloud to store data, send emails, or push notifications, kick off workflows, and so on. Node is ideal for building highly scalable, data-intensive, and real-time backend services that power our client applications. Now you might ask, but Mosh, there are other tools and frameworks out there for building backend services such as ASP.NET, Rails, Django, and so on. So what's so special about Node? Well, Node is easy to get started and can be used for prototyping and agile development. But it can also be used for building super fast and highly scalable services. It's used in production by large companies such as PayPal, Uber, Netflix, Walmart, and so on. In fact, at PayPal, they rebuilt one of their Java and Spring-based applications using Node, and they found that the Node application was built twice as fast with fewer people, in 33% fewer lines of code, and 40% fewer files. And more importantly, they doubled the number of requests served per second while decreasing the average response time by 35%. So Node is an excellent choice for building highly scalable services. Another reason for using Node is that in Node applications we use JavaScript. So if you're a front-end developer and know JavaScript, you can reuse your JavaScript skills and transition to a full-stack developer and get a better job with better pay. You don't have to learn a new programming language. Also, because you can use JavaScript both on the front end and on the back end, your source code will be cleaner and more consistent. So you will use the same naming conventions, the same tools, and the same best practices. And finally, another reason for using Node is that it has the largest ecosystem of open source libraries available to you. So for pretty much any features or building blocks you want to add to your application, there is some free open source library out there that you can use. So you don't have to build these building blocks from scratch, and instead you can focus on the core of your application. Next, we're going to look at the architecture of Node. So in the last video, you learned that Node is a runtime environment for executing JavaScript code. But what is a runtime environment really? Well, before Node, we used JavaScript only to build applications that run inside of a browser. So every browser out there has what we call a JavaScript engine that takes our JavaScript code and converts it to code that a computer can understand. For example, Microsoft Edge uses Chakra, Firefox uses SpiderMonkey, and Chrome uses V8. And it's because of these varieties of engines that sometimes JavaScript code can behave differently in one browser or another. Now, a browser provides a runtime environment for JavaScript code. For example, you probably know that in browsers, we have the window or the document object. These objects allow us to work with the environment in which our code is running. Now, up to 2009, the only way to execute JavaScript code was inside of a browser. In 2009, Ryan Dahl, the creator of Node, came up with a brilliant idea. He thought it would be great to execute JavaScript outside of a browser. So he took Google's V8 engine, which is the fastest JavaScript engine out there, and embedded it inside a C++ program and called that program Node. So similar to a browser, Node is a runtime environment for JavaScript code. It contains a JavaScript engine that can execute our JavaScript code. But it also has certain objects that provide an environment for our JavaScript code. But these objects are different from the environment objects we have in browsers. For example, we don't have the document object. Instead, we have other objects that give us more interesting capabilities. For example, we can work with the file system, listen for requests on a given port, and so on. We can't do stuff like that inside of a browser, right? So, in essence, Node is a program that includes the V8 JavaScript engine plus some additional modules that give us capabilities not available inside browsers. We can work with the file system or the network and so on. Both Chrome and Node share the same JavaScript engine, but they provide different runtime environments for JavaScript. Now, I've seen people comparing Node to C# or Ruby or some other programming languages. But these comparisons are fundamentally wrong because Node is not a programming language. It's like comparing a car with an apple. By the same token, Node should not be compared with frameworks such as ASP.NET or Rails or Django and so on. These are frameworks for building web applications. Node is not a framework. It's a runtime environment for executing JavaScript code. Next, we're going to look at how Node works. So earlier I mentioned that Node applications are highly scalable, and this is because of the non-blocking or asynchronous nature of Node. What do I mean by asynchronous? Let me give you a metaphor. Imagine you go to a restaurant. A waiter comes to your table, takes your order, and gives it to the kitchen. Then they move on to serve another table while the chef is preparing your meal. So the same person can serve many different tables. They don't have to wait for the chef to cook one meal before they serve another table. This is what we call non-blocking or asynchronous architecture. And this is how Node applications work. The waiter is like a thread allocated to handle a request. So a single thread is used to handle multiple requests. In contrast to non-blocking or asynchronous architecture, we have blocking or synchronous architecture. Let's see how that works. So back to our restaurant example, imagine you go to another restaurant, and in this restaurant, a waiter is allocated to you. They take your order and give it to the kitchen. Now they're sitting in the kitchen waiting for the chef to prepare your meal. At this time, they're not doing anything else. They're just waiting. They're not going to take an order from another table until your meal is ready. This is what we call blocking or synchronous architecture. And that's how applications built with frameworks like ASP.NET or Rails work out of the box. So when we receive a request on the server, a thread is allocated to handle that request. As part of handling that request, it is likely that we're going to query a database. And as you know, sometimes it may take a little while until the result is ready. When the database is executing the query, that thread is sitting there waiting. It can't be used to serve another client. So we need a new thread to serve another client. Now imagine what would happen if we have a large number of concurrent clients. At some point, we're going to run out of threads to serve these clients. So new clients have to wait until free threads are available, or if we don't want them to wait, we need to add more hardware. So with this kind of architecture, we are not utilizing our resources efficiently. This is the problem with blocking or synchronous architecture, and as I explained, that's how applications built with frameworks like ASP.NET work by default. Of course, in ASP.NET, it is possible to use asynchronous architecture, but you will have to do extra work for that. In contrast, Node applications are asynchronous by default, so you don't have to do anything extra. In Node, we have a single thread to handle all requests. When a request arrives, that single thread is used to handle that request. If we need to query a database, our thread doesn't have to wait for the database to return the data. While the database is executing our query, that thread will be used to serve another client. When the database prepares the result, it puts a message in what we call an event queue. Node is continuously monitoring this queue in the background. When it finds an event in this queue, it will take it out and process it. This kind of architecture makes Node ideal for building applications that include a lot of disk or network access. We can serve more clients without the need to throw in more hardware, and that's why Node applications are highly scalable. In contrast, Node should not be used for CPU-intensive applications like a video encoding or an image manipulation service. In this kind of applications, we have a lot of calculations that should be done by CPU, and few operations that touch the file system or the network. Since Node applications are single-threaded, when performing the calculations to serve one client, other clients have to wait. And that's why Node should not be used for CPU-intensive applications. It should only be used for building data-intensive and real-time applications. Okay, enough theory. Next, I'm going to show you how to install Node and build your first Node application. In this lecture, I'm going to show you how to install Node. If you're on Windows, open up Command Prompt. If you're on Mac or Linux, open up the terminal. First, let's see if you already have Node on your machine or not. So run node space dash dash version. You can see on this machine, I'm running Node version 6.10.3. This is an earlier version of Node. The latest stable version is version 8. Now, on your machine, chances are you may not have Node or you might have an earlier version. Either way, I want you to install the latest version of Node. So open up your browser and head over to node.js.org. On this homepage, you can see we have two versions for Node. One is the latest stable version, which is recommended for most users. At the time of recording this video, that's version 8.9.1. And there's always a newer version, which is experimental, and it might not be stable. So I want you to install the latest stable version. Also, take into account that in the future, when you're watching this video, chances are the latest stable version might be newer. If you're worried that this course is going to get outdated, don't worry. Because in this course, we're going to focus on the fundamentals. So I'm going to work with the core modules of Node. These core modules are stable. They have been there for a long time. So the code that we're going to write in this course will continue to work with the future versions of Node. Once you master the fundamentals, you can always learn about the new features that come in every version by looking at the changelog. So let's not worry about the fancy new features in Node and focus on the fundamentals. So let's go ahead and install the latest stable version. You can see here I get a package. We run it. It's an installer. Take a look. Very simple. Just continue, 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 install. We need to enter our password. And the installation is complete. It took only a few seconds. So now, back in the terminal, let's run node -- version one more time. You can see I upgraded my Node to version 8.9.1. Next, we're going to build our first Node application. All right, now we're ready to build our first Node application. So I'm going to create a new folder. Call it first app. Let's go to this folder. Now I'm going to open this folder inside of Visual Studio Code, which is my preferred code editor. So code, period. So this is Visual Studio Code or VS Code. It's a free, powerful editor, but you can use any editors that you prefer. You can use Sublime, you can use Atom, or any other editors. So here in this folder, I'm going to add a new file, app.js. In this file, we can write regular JavaScript, just like the JavaScript that we write for the browsers. So I'm going to define a function, say hello, that takes a parameter, name, and simply logs a message on the console. So hello plus name. And then we can call this function like this, mosh. Now to execute this code, we're going to go back to the terminal and run node and pass the name of the file as an argument. So app.js. So Node, as I told you before, is a C++ program. It includes Chrome's V8 JavaScript engine. So this app.js file that we're going to pass to Node, Node is going to give it to V8 for execution. So you can see we got hello mosh on the console. Now let me show you something. So back in VS Code, I'm going to temporarily comment out this line and do a console.log of window. Let's see what happens. So back in the terminal, let's run node app node.js. We got an exception. Window is not defined. So as I told you before, in Node, we don't have the window or document objects. These are part of the runtime environment that we get with browsers. In Node, we have other objects to work with files, with the operating system, with the network, and so on. And that's what you're going to learn about in the next section. I hope you enjoyed this section, and thank you for watching. In this section, we're going to look at the module system in Node. You will learn what modules are, why we need them, and how they work. Throughout this section, we'll explore a few of the modules built into the core of Node, such as operating system, file system, events, and HTTP. You will also learn how to create your own modules. Now, let's get started. So in the last section, we used this console.log function to log something on the console. Now this console object is what we call a global object. So it's part of the global scope, which means we can access it anywhere in any files. We have a bunch of other objects and functions that are also globally available in Node. For example, we have setTimeout, which you have probably seen before. We use this to call a function after a delay, like 1 second, 2 seconds, whatever. So this is just part of the standard JavaScript. We can use this on the client. We can use this inside of a browser or inside of Node. We also have clear timeout. Similarly, we have setInterval, which we use to repeatedly call a function after a given delay. We also have clear interval, which we use to stop that function from being called repeatedly. So these are the global objects in JavaScript. Now in Node, we have a couple other global objects that you're going to learn about later in this section. Now in browsers, we have this window object that represents our global scope. So all the variables and functions that are defined globally, we can access them via this window object. So we can call window.console.log or simply just console.log. The JavaScript engine will prefix this statement with window.console.log because that's where this object is defined. Similarly, all these other functions you see here, they belong to the window object. So we can call window.setTimeout or call it directly. By the same token, when we declare a variable, let's say message, that variable is also available via the window object. Okay? However, in the last section, I told you that in Node, we don't have this window object. Instead, we have another object called global. So all these functions and objects we have here, we can access them via the global object. So we can do global.console.log or global.setTimeout and so on. Of course, it's easier to use the shorthand instead of prefixing them with this global. But one thing you need to know about Node is that these variables that we define here, they are not added to the global object. In other words, if we do a console.log of global.message, we're going to see undefined on the console. So let me show you. I'm going to delete all the code here. Now, back in the terminal, let's run node app.js. So we get undefined in the console. So as you can see, the variables and functions that we define here, they are not added to the global object. They're only scoped to this file, app.js. So they are not available outside of this file. And this is because Node's modular system that you're going to learn about in the next lecture. So in the last section, you'll learn that in the client-side JavaScript that we run inside of browsers, when we declare a variable or a function, that is added to the global scope. For example, when we define a function, like say hello, that function is added to the global scope and it's available via the window object. Now, there is a problem with this behavior. In a real-world application, we often split our JavaScript code into multiple files. So it is possible that we have two files And in both these files, we define this function, say hello, with the exact same name. Because this function is added to the global scope, when we define this function in another file, that new definition is going to overwrite the previous definition. So this is the problem with the global scope. So in order to build reliable and maintainable applications, we should avoid defining variables and functions in the global scope. Instead, we need modularity. We need to create small building blocks or modules where we define our variables and functions. So two variables or two functions with the same name don't overwrite another variable or function defined somewhere else. They're encapsulated inside of that module. Now, at the core of Node, we have this concept called module. So every file in a Node application is considered a module. The variables and functions we define in that file or that module are scoped to that file. In object-oriented programming terms, we say they are private. They are not available outside that container, outside that module. If you want to use a variable or a function defined in a module outside that module, you need to explicitly export it and make it public. And we're going to look at that in the next lecture. So what I want you to take away from this lecture is that every Node application has at least one file or one module, which we call the main module. So in this case, this app.js is our main module. Now let me show you this module. So I'm going to delete all this code here and do a console.log of module. Now this module object here may appear to be global. So you may think we can access it via the global object, like global.console, but actually this is not a global object. It appears to be global, but it's not global, and you will find out why very soon. So let's just log this module object and see what we see in the console. Back in the terminal, node app.js. So you can see we have an object, module. It's a JSON object with these key value pairs. So we have ID. Every module has an ID or a unique identifier. We have exports, parent, file name, which is the complete path to that file, loaded, which is a Boolean that determines if this module is loaded or not. We have children and paths. Now for now, don't worry about these properties. As we go through this section, you will gradually become familiar with these properties. So in Node, every file is a module, and the variables and functions defined in that file are scoped to that module. They're not available outside of that module. In the next lecture, you're going to learn how to create and load a module. All right, now let's add a new module to this application. So I'm going to add a new file, logger.js. Let's imagine we're going to create a module for login messages, and we're going to reuse this module in various parts of this application or potentially in other applications. So logger.js. Now in this module, let's imagine that we're going to use one of those remote logging services for logging our messages. So there are websites out there that provide logging as a service. They give us a URL and we can send an HTTP request to that URL to log messages in the cloud. So here, I'm going to declare a variable like URL and set it to something like this, HTTP mylogger.io/log. And of course, I'm making this up. It may not be a true service out there, but let's imagine in this implementation, we're going to send an HTTP request to this endpoint, to this URL. Now we also need a function called log that takes a message. And in this function, we're going to send an HTTP request. However, to keep things simple here, we just want to focus on the modularity. We don't want to get distracted with all the details of sending HTTP requests. So for now, I just want to log this message on the console. So console.log message. Okay. Now, this variable and this log function, they're both scoped to this module. They're private. They're not visible from the outside. However, in app.js, which is our main module, we want to use this logger module. So we should be able to access this log function we should be able to call it from the app module. So we need to make this public. We need to make it visible from the outside. Now, in the last lecture, you saw this module object. One of the properties we have here is exports. You can see this property is set to an empty object. Anything that we add to this object will be exported from this module, and it will be available outside of this module. So back in our logger module, I'm going to set module.exports.log. So I'm adding a method called log to this exports object and simply setting it to this log function we have defined here. Okay? In other words, the object that we're exporting here has a single method called log. Now, similarly, if you want to export this URL, we could do something like this. So module.exports.url, we set it to URL. And of course, we could change the name that is exported to the outside. For example, internally, we may call this variable URL, but when we export it, we may call it endpoint. Okay? Now, in this case, we don't need to export this URL variable because this is purely implementation detail. So in real-world applications, every module might have several variables and functions. We only want to export a subset of these members to the outside because we want to keep this module easy to use. Let me give you a metaphor. Think of a DVD player. A DVD player has a few buttons on the outside, and these are the buttons or objects that we interact with. So these objects represent the public interface of a DVD player, okay? But inside the box, there are lots of other objects. They're complex objects. We don't need to know anything about these objects. They're implementation detail, and they can change significantly from one model to another. But what we see on the outside is almost stable or static across different models. So in our logger module, this URL is implementation detail. Other modules don't need to know anything about this. They only need to call the log function. So we export this, make it public, but keep the URL private. So I'm going to delete this last line. Okay, so we're done with our logger module. Now we need to load this module and use it inside app.js. To load the module, we use the require function. This is one of the functions in Node. We don't have this in browsers. This function takes one argument, and that's the name or path of the target module we want to load. So here we want to load the logger module. Now we can see both the app module and logger module are in the same folder. So we use / to indicate the current folder. And then we add the name of our module, that is logger.js. Or we can make it shorter and just use logger, because Node assumes this is a JavaScript file and it automatically adds the JS extension. Now, if this logger was in a subfolder, we could add that subfolder here. Or if it was in the parent folder, we could use .. So here we're using the relative path to the target module. In this case, that module is in the same folder. Now, this require function returns the object that is exported from this target module. So this exports object here, this is what we get when we call the require function. Let me show you. So I'm going to declare a variable, call it logger, the name of the module, and set it to the return value of the require function. Now let's log this logger and see what we get. So node app.js, look, we get an object. This object has a single method called log. You can see that's a function. So we can call this function or this method in app.js. So back here, we call logger dot, and look, here we have IntelliSense in VS Code. So we call log and pass a message. Now, back in terminal, let's run this app. And we get message on the console. So this is how we work with modules in Node. When we define a module, we export one or more members. And then to load the module, we use the require function. Now, in the recent versions of JavaScript, we have the ability to define constants. So as a best practice, when loading a module using the require function, it's better to store the result in a constant, like this. The reason for this is because we don't want to accidentally overwrite the value of logger like this here. If we set this to 1, then when we call the log method, we're going to get an exception. Let me show you. So one more time. Look, we got logger.log is not a function. Now, in contrast, if we define this as a constant, now back in the terminal, let's run this program one more time. Look, we got a different kind of error, assignment to constant variable. Now, there are tools out there that check our JavaScript code for errors like that. So by using these constructs properly, we can prevent these errors from happening at runtime. So one of these popular tools is JS Hint. If you have never used it before, don't worry, I'm just going to show you a quick demo. So if you run JS Hint app.js, we get this error, attempting to overwrite logger, which is a constant. So with tools like JS Hint, we can scan all our JavaScript code for errors like that. So that's the benefit of using a constant as opposed to a variable here. If we accidentally reset this object, then we're going to get an error at compile time instead of at runtime, okay? And one last thing before we finish this lecture. Sometimes, instead of exporting an object from a module, you may want to export only a single function. For example, here in our logger module, we don't necessarily need an object because we have a single method. An object would be useful if we had multiple methods or properties here. But in this case, instead of exporting an object, we can export a single function. So we can reset this exports to the log function. So initially it was an empty object, but we reset it to just a function. With that, back in app.js, so logger is no longer an object, it's a function that we can call directly, like this. So logger, we call it and give it an argument. Now a better name for this function is log. So I'm going to press F2 to rename this, log, like this. Now, back in terminal, let's run node app.js, and we get the same result. So in your modules, you can export a single function or an object. So now you know the variables and functions we define in a module are scoped to that module. They're private and not visible from the outside. But you might be wondering how Node does this. So let me show you. On the very first line of the logger.js module, I'm going to create a syntactical error. So define a variable x and set it to nothing, like this. So make sure to write this code on the very first line. In other words, if you have a line break here and do this on the second line, you're not going to see what I'm going to show you now. So put this back on the first line. Here we have a syntactical error. Now, back in the terminal, let's run the application again. Okay, we got unexpected token, semicolon, right? But look above this line. You see this function declaration. So this function has a few parameters: exports, require, module, file name, and dir name. So let me copy this code here. Now basically what happens under the hood is that Node does not execute this code directly. It wraps it inside of a function, and that's the function you saw. So at runtime, our code is going to be converted to something like this. So we have this function declaration. Here's the body of that function. Now for now, I'm going to remove this error here. So this is our code. And then we have the end of this function. Now the actual code is slightly more complicated than this, but we don't want to get distracted with that complexity. If you're a more advanced JavaScript developer, You probably know this is an immediately invoked function expression, or IFI. If you don't know that, don't worry, that's not really the scope of Node. What I want you to take away here is that Node does not execute our code directly. It always wraps the code inside each module in something like this, inside of a function. Now look at these arguments to this function. So you have seen the require function. I told you that this require function appears to be global, but actually it's not global. In fact, it's local to each module. So in every module, require is one of the arguments that is passed to this function. We call this function the module wrapper function. Okay? So you have seen the require function. You have also seen module. That is what we're using here. So we have module.exports. We also have exports, which is a shortcut to module.exports. So if you want to add a function to module.exports object, you can either write module.exports.log equals log, or you can write exports.log equals log. But you cannot reset this exports like what we did earlier. In other words, you cannot write exports equals log, because this exports is a reference to module.exports. You cannot change that reference, okay? So these are the first three arguments. We also have file name and dir name, which represent the name of this file and the path. So let's have a quick look at these arguments. On the top, I'm going to do a console.log of underline file name and also underline dir name. Now, we're not going to have this function, this module wrapper function. This was purely for demonstration. So I'm going to revert the code back to what we had before. Okay. So now we don't have any errors in this module. Let's go back to the terminal and run this program. So node app.js. So here on the first line, we have file name, which is the complete path to that file, that is logger.js. And on the second line, we have the path to the directory that contains that module. So now you have a basic idea about Node modules and how they work. You know how to create them, how to load them. But Node itself comes with a bunch of useful modules that we can use in a lot of applications. And that's what we're going to look at in the next lecture. Hi guys, thank you for watching my Node tutorial. I wanted to let you know that this tutorial is the first hour of my complete Node course, where you will learn how to build a real RESTful API using Node, Express, and MongoDB, all of that recorded with the latest version of Node and modern JavaScript. So you will learn the new and modern ways of building applications with Node. Unlike other courses that only show you simple, dummy examples like how to build a to-do app, we're going to work on a real-world project, a RESTful API for a video rental application. If you have taken any of my courses, you know I don't waste your time by explaining the obvious, like what a code editor or command prompt is. We're going to get straight to the business. And as part of this, I'll be touching on various important topics that you need to understand really well, including working with Node Package Manager or NPM, asynchronous JavaScript, including callbacks, promises, async and await, implementing CRUD operations, data validation, authentication and authorization using JSON Web Tokens, including role management, handling and login errors, unit and integration testing, test-driven development. So you will see I will build a feature from A to Z using test-driven development or TDD. And finally, we'll deploy this application to the cloud. Throughout the course, I will share with you lots of clean coding and refactoring techniques, security best practices, useful libraries to use as part of your development, common mistakes that many Node developers make, and much, much more. The course is currently 14 hours long, and I'm planning to add more content to it in the future. You can watch this course as many times as you want, and if you watch it to the end, you will get a certificate of completion that you can add to your resume. So, if you're serious about adding Node to your resume, I highly encourage you to enroll in the course and don't waste your time jumping from one tutorial to another. So, click on the link in the video description to enroll. I hope to see you in the course. So in the last lecture, I told you that in Node, we have a few useful modules that are built into the core of Node. With these modules, we can work with files, with the operating system, with the network, and so on. So let's have a quick look at these built-in modules. Head over to node.js.org, then go to docs. On the left side, go to version 8.9.3. That's the current stable release. Chances are by the time you're watching this video, this version might be different. So that doesn't really matter. Just pick that version. Now here in the table of contents, you can see the built-in modules. Of course, not everything you see here is a module. For example, we have console, which is our console object. We have buffer, which we are going to learn about in the future in this course. Again, that's a global object, but you can see that this is a fairly short list. And some of the items in this list are built-in modules in Node. So just that. You can see there are not many modules built into Node. I'm going to highlight a few very useful modules that you should be aware of. For example, we have file system to work with files. We have HTTP that you're going to learn about later in this section. So with this, we can create web servers that listen for HTTP requests. We have OS to work with the operating system. We have path, which gives us a bunch of utility functions for working with paths. We have process that gives us information about the current process. We have query strings, which is very useful in building HTTP services. We have a stream, which allows us to work with streams of data. Again, you're going to learn about this in the future, and a bunch of other modules. Now, in this lecture, we're going to look at this path module. So on the documentation, you can see all the functions defined in this module. In this lecture, we're going to use the parse method. Now, if you scroll down, you can see how you can use this module. So you have seen the require function before. We call the module using the require function, get the result, which is an object, and store it in a constant. So back in VS Code, in app.js, let's call require, and as the argument, use path. Now, the argument that we give to this require function, Node assumes that this is a built-in module. If there is no built-in module by the name specified here, then Node looks for the existence of a relative path to a file in this application. So if we have period slash or period slash whatever, then Node assumes that this is a file in this application. Now, in this case, we're going to load the built-in path module and store it in a constant called path. So this is an object with a bunch of useful methods. The method we're going to use is the parse method. So I'm going to give it this underline file name, which is one of the arguments in the module wrapper function that you saw in the last lecture. So let's call this and store the result in path object. And then finally, log it on the console. Path object. Now back in the terminal, let's run this application. So this is the path object. It has a few useful properties. We have root, we have dir, which specifies the path to the folder containing this file. Here's the name of the file, app.js. Here's the extension, and here's the name of the file without the extension. So if you want to work with paths, it's much easier to use the path module as opposed to working with strings. In the next lecture, we're going to look at another built-in module that gives us information about the operating system. In this lecture, I'm going to show you how to get information about the current operating system. So back in Node documentation, in the list of modules, if you scroll down, you can see this OS module. Let's have a quick look here. So these are the methods that are available in this module. For example, we have freemem, which returns the amount of free memory on this machine. We also have totalmem, which is the total memory. We can get information about the current user. We can get the uptime of this machine, and so on. So let's use a couple of these methods here. So if you scroll down, you can see this is how we load this OS module. Just like loading other modules, We call the require function and store the result in a constant called OS or anything. So back in VS Code, I'm going to delete all the code here and define a new constant, OS, and set it to require OS. Now we can call total mem method or free mem or other methods. So let me declare a variable and store the result here. And similarly for the free memory. And finally, let's log these values on the console. So console.log, single quote, we add total memory and append this total memory here. Now we can simplify this expression by using a template string, which is available in more recent versions of JavaScript that we refer to as ES6 or ES 2015, which is short for ECMAScript 6 or 2015. That's the specification that defines what features are available in JavaScript. So every year, ECMA defines new features that should be added to JavaScript. And as you know, different browsers implement different set of these features. But the V8 engine that we have inside of Node, that's pretty up to date, and it implements a lot of new features of JavaScript that is defined in ECMAScript. So in ECMAScript 6 or ECMAScript 2015, we have a feature called template string, which helps us build a string without concatenations. Let me show you how that works. So console.log. Now, instead of a single quote, we use the backtick character. Backtick is the character before number 1 on your keyboard. So here we add some static text like total memory. Now we want to add something here dynamically. So we use $sign and curly braces to add a placeholder for an argument. In this case, our argument is this total memory variable. So we can see with a template string, we don't have concatenation. Okay. Now I'm going to duplicate this line and change total to free. And here let's add free memory. Okay. Now we don't need this first console log. We're done with this. Let's go back to the terminal and run this application. So node app.js, and you can see the total and free memory on my machine. Now what is interesting here is that before Node, we could not get this kind of information using JavaScript. JavaScript used to run only inside of a browser, and we could only work with the window or document objects. We couldn't get information about the operating system. But when using Node, our JavaScript code is executed outside of a browser, or as some people say, on the server. With this, we can get information about the operating system. We can work with files. We can work with the network. For example, we can build a web server that listens for HTTP requests on a given port. And I'm going to show you all this later in this section. In this lecture, I'm going to show you how to work with files in Node. So back in Node documentation, in the list of modules, here we have a module called File System. In this module, we have a comprehensive set of methods for working with files and directories. Now in this course, I'm not going to waste your time showing you every single method here because that would be very repetitive. But let me show you an example so you see how to work with files in Node. So back in VS Code, first we need to require the fs module. We get the result and store it in this constant. Now fs dot, look, almost every operation defined here comes in two forms: synchronous or blocking and asynchronous or non-blocking. For example, look, we have access, which is an asynchronous method. We also have access sync, which is a synchronous method. Now, even though we have these synchronous methods here, you should avoid using them. These are there purely for simplicity. In a real-world application, you should use asynchronous methods because these are non-blocking. So as I told you in the last section, a Node process has a single thread. If you're using Node to build the backend for your application, You might have several hundreds or thousands of clients connecting to that backend. If you keep that single thread busy, you won't be able to serve many clients. So always use asynchronous methods. Now that aside, let's take a look at an example. We're going to look at read dir or directory method. First, I'm going to show you the synchronous form because that's easier to understand. So, as the first argument, we specify the path. Period slash represents the current folder, and this will return all the files and folders in the current folder. So, files will be a string array. Now we can display that on the console. Very simple. So node app.js. So we can see we get an array of strings, and these are the files in this folder on my machine. Now let's take a look at the asynchronous form of this method. So fs.read directory. Just like before, the first argument is the path. So the current folder. Now all these asynchronous methods take a function as their last argument. Node will call this function when that asynchronous operation completes. We call this function a callback. So here, look, in the IntelliSense, the second parameter is a callback, and this is a function with two parameters, an error and result, which is in this case a string array. So here we need to pass a function or a callback function with an error and the result, which is a string array. We can call that files. So here we need to check if we have an error or the result. Only one of these arguments will have a value and the other will be null. So if we have error, we're going to display it on the console. Error, error. Now, this is not how we handle errors in a real-world application, but don't worry about this. Later in the course, we have a complete section about error handling in Node. For now, we just want to display this error on the console. So if you have an error, we display it. Otherwise, we display the result. So console.log result, and we can display this string array. So I'm going to comment out these two lines so we can only look at the result of this asynchronous read directory. Now node app.js. So we got result, and this is exactly the string array that we had before. Now let's simulate an error. So I'm going to go back in the code and change this argument to, let's say, a $sign. Save. Back in the terminal. Node app.js. This time we got an error. No such file or directory. So to recap, in order to work with files and directories in Node, first you need to require the fs module and then use one or more of the methods defined in this module. All these methods come in pairs, asynchronous and synchronous. Always prefer to use asynchronous methods. One of the core concepts in Node is the concept of events. In fact, a lot of Node's core functionality is based on this concept of events. An event is basically a signal that indicates that something has happened in our application. For example, in Node, we have a class called HTTP that we can use to build a web server. So we listen on a given port, and every time we receive a request on that port, that HTTP class raises an event. Now, our job is to respond to that event, which basically involves reading that request and returning the right response. So as you go through Node's documentation, you can see that several classes in Node raises different kinds of events. And in your code, you might be interested to respond to those events. So in this lecture, I'm going to show you how to work with the events module. Now, back in Node's documentation, once again, in the list of modules, you can see here we have this events module. So in this module, we have one class that is called event emitter. It's one of the core building blocks of Node, and a lot of classes are based on this event emitter. So let's see how we can work with this event emitter. Back in VS Code, first, let's load the events module. So require events. Now here, when we call the require function, we get the event emitter class. So constant event emitter. Note that here, in terms of the naming, the first letter of every word is uppercase. This is a convention that indicates that this event emitter is a class. It's not a function, it's not a simple value, it's a class. A class is container for properties and functions which we call methods. So in this event emitter class, we have these methods that you see here in the documentation. So a class is a container for a bunch of related methods and properties. Now here, in order to use this event emitter, first we need to create an instance of this class. So constant emitter, we set this to new event emitter. So here, this emitter is an object. In case you don't know the difference between a class and an object, let me give you a metaphor. A class is like human, and an object is like an actual person, like John, Mary, and so on. So a class defines the properties and behavior of a concept, like a human, but an object is an actual instance of that class, okay? So here, this first event emitter is a class. It's a blueprint. It defines what an event emitter can do. But this second emitter is an actual object. This is the one that we're going to use in our application. So this emitter has a bunch of methods. Look, these are all the methods that you saw in the documentation. Now, even though here we have more than 10 methods, most of the time we use only 2 of these methods. One is emit, that we use to raise an event. The first time I saw this method, it didn't make sense to me because English is my second language and I didn't know what emit means. So if you're in the same boat, emit basically means making a noise or produce something. In this case, we're making a noise in our application. We're signaling that an event has happened. Okay? So that's the meaning of emit. Now here, we pass an argument that is the name of the event. Let's say message logged. In the future, we're going to extend our logger module, and every time we log a message, we're going to raise an event called message logged. Okay? Now, if we run this application, nothing is going to happen. Let me show you. Back in the terminal, node.js, look, nothing happened. Because we have raised an event here, but nowhere in our application, we have registered a listener that is interested in that event. A listener is a function that will be called when that event is raised. Okay? So let's register a listener that will be called when the message logged event is raised. So register a listener. So emitter dot, look, here we have this method add listener, but we have an alias for this that we use more often. That is on. If you have worked with jQuery, you have seen this before. So on or add listener, they're exactly the same. But quite often we use the on method. Now this method takes 2 arguments. The first one is the name of the event. In this case, message logged. And the second one is a callback function or the actual listener. So here we pass a function, and this function will be called when that event is raised. Okay? Now for now, I just want to log a message in the console. So console, let's say listener called like this. Now let's run this application. So node app.js, and we got this message, listener called. So this indicates that when we raise this event, this callback function or listener was called. Okay? And of course, the order is important here. If we registered this listener after calling the emit method, nothing would have happened. Because when we call the emit method, this emitter iterates over all the registered listeners and calls them synchronously. Okay? So this is the basic of raising events and handling them using the event emitter class. Now, quite often, when we want to raise an event, we also want to send some data about that event. For example, In our logger module, when we log a message, perhaps our remote login service will generate an ID for that message. Perhaps we want to return that ID to the client. Or it may give us a URL to access that logged message directly. So here, when raising an event, we can add additional arguments, which we refer to as event arguments. So we can add an ID, like one, and we can add a URL. But as you can see, these magic values here are a little bit confusing. If you want to send multiple values about an event, it's a better practice to encapsulate those values inside an object. So here, we add an object, we give it a couple of properties like ID, we set it to ID of this message that is logged, and another property URL like this, okay? So we refer to this object as event argument. Now, when registering a listener here, this callback function, this actual listener, can also receive this event argument. So here we add a parameter called arg. You can call it anything. The name doesn't matter. But by convention, we often use arg, or some people use e to refer to the event, or event arg. Whatever you prefer is perfectly fine. So here we have arg. Now, let's log it on the console. Very simple. Let's run this application. So node. Okay, look, listener called, and here's our event arg. And with this technique, we can pass data about the event that just happened. Now, one last thing to make this code a little bit simpler. In ES6 or ECMAScript 6, we have this feature called arrow function. With an arrow function, we can get rid of this function keyword. So here we have the arguments, and after that, we have the body of that function. Now, to separate the two, we use an arrow, and that's why we call this arrow function. You can see this syntax is a little bit simpler, and a lot of people prefer to use arrow functions in ES6. Now, here's a simple exercise for you. Let's imagine in our logger module, just before calling our remote service to log the message, we're going to raise an event called logging. And while raising this event, we also want to send some data. That is the message that we're going to log. So what I want you to do is to use what you have learned in this lecture and raise and handle this logging event. It's a very simple exercise. I just want you to get used to this syntax. Now, in the real world, it's quite rare that you would work with this event emitter object directly. Instead, you want to create a class that has all the capabilities of the event emitter, and then you will use that class in your code. Let me explain what I mean by that and why. So let's open up our logger module. So in this module, we're exporting a simple function, log, right? And here, we log that message on the console. Now, after this, we want to raise an event. And then later in app module, we will listen for that event and do something. So let's go back to our app module and copy some code into the logger module. So on the top, I'm going to copy these two lines to bring the event emitter in this module. Okay, now back in app module, I'm also going to move these two lines for raising an event into the logger module, because this code should not be here. It's the logger module that emits or signals an event, saying the message is logged. So cut. So here, after we log the message, we raise an event like this. Okay. Now back in app module, we don't need this comment. Here we need to load the logger module and call the log function. So constant log, we call the require function and set the path to the logger module. And here we simply call the log function with a message. Okay. Now, when we run this application, we are only going to see this message on the console. In other words, this event listener will not be called. Let's verify that, and then I will explain why that happens. So back in terminal, node app.js. Look, we only got the message on the console. So our event listener was not called. The reason for this is because here we're working with two different event emitters. In app.js, we have this event emitter object, and in logger module, we have another event emitter object. So earlier I told you that a class is like a blueprint and an object is an actual instance. As a metaphor, I said we could have a class called human or person, but the objects could be Jack, John, Mary, Bob, whatever. So in this case, we have two different objects. In the logger module, we're using this emitter object to emit an event, whereas in app module, we're using another event emitter object to handle that event. These are completely different. So when we register a listener here, that listener is only registered with this event emitter, which is completely different from the other event emitter. So that's why I told you in your applications, it's very rare that you would want to work with this event emitter directly. Instead, you want to create a class that has all the capabilities of this event emitter, but it has additional capabilities. In this case, we want to create a class called logger that has this additional method, log. Okay, so the first thing we want to do here is to define a class. In ES6, we have this keyword class, which is a syntactical sugar for creating a constructor function. With this, we can define a class, logger. Note that the first letter of every word in a class should be uppercase. This is the Pascal case convention that we use for naming classes. So class logger, we have a code block. Now we need to move this log function inside this logger class. So cut, paste it here. Now we have an error because when we define a function inside a class, we don't need this function keyword. And from now on, we refer to this function as a method. So when a function is inside a class, we say that's a method in that class. Okay? So here we have this logger class. Now, at the end, instead of exporting the log function, we're going to export the logger class. Okay? Now we want this logger class to have all the capabilities of this event emitter. The way we do that is by using the extends keyword that comes in ES6. So extends, and here we add the name of the parent or the base class. So event emitter. And with this simple change, this logger class will have all the functionality that is defined in event emitter. So here, when raising this event, instead of using this emitter object, we're going to use this. So in this class, we can directly emit or raise events. Okay? And now we no longer need this actual emitter object because we have not used it anywhere in this code. So delete. We're done with the logger module. Now, back in the app module. So here, when requiring the logger module, we get a class. So I'm going to rename this to logger with capital L. That's a class. Now we create an object. So new logger. And then to log a message, we call logger.log. Now, similar to the change that we made in the logger module, we no longer need this event emitter object here. We want to work directly with this logger object. So we're going to register this listener on this logger object. Okay? So I'm going to move this code after creating the logger. We say, hey logger, when you raise this message logged event, I want to execute this code. Okay? And finally, you can see we no longer need this event emitter object. It's not used anywhere. Delete. Now, when we run this application, we're going to see this message on the console, but also because we're using the same logger object for registering an event listener and also raising an event, we're going to see this message on the console. So node app.js, look, this is the message on the console. And you can see our listener was successfully called. So let's quickly recap. If you want to raise events in your application to signal that something has happened, you need to create a class that extends event emitter. With this, that class will have all the functionality defined in event emitter, but you can also add additional functionality. In this case, we have the ability to log a message. And then inside that class, whenever you want to raise an event, you use this.emit because this references this logger class itself, which extends event emitter. So all the methods defined in event emitter will also be part of this class. Okay? And finally, in app module, again, instead of using an instance of event emitter, you will use an instance of the custom class that you have defined that extends event emitter. One of the powerful building blocks of Node is the HTTP module that we use for creating networking applications. For example, we can create a web server that listens for HTTP requests on a given port. And with this, we can easily create a backend service for our client applications, like a web application that we build with React or Angular, or a mobile application running on a mobile device. So once again, back in the Node documentation, in the list of modules, you can find this HTTP module. In this module, you can see various classes like http.agent, http.clientRequest, and so on. Each of these classes has a bunch of properties, methods, and events. So back in VS Code, let's load the HTTP module. So constant HTTP, we set it to require HTTP. Okay. Now here we can call http.createServer. This is one of the functions defined in this module. And with this, we can create a web server. So let's store the result in a server object. Now, what is interesting is that this server is an event emitter. So it has all the capabilities of event emitter that you saw earlier in this section. So look, server dot, we have the on method or add listener or emit and so on. Also, if you look at the documentation for the HTTP module, on this page you can see http.serverClass. Here the documentation says that this class inherits from net.server. So this is another class defined in the net module. Let's have a look. Now here, the documentation says that net.server is an event emitter. So that's why I said a bunch of Node's core functionality is based on event emitter. So back to our server object, now we can call server.listen and give it a port. Let's say port 3000. Now following that, I'm going to add a console.log saying listening on port 3000. Okay. Now when we run this application, this server will listen on port 3000. As I told you before, every time there is a new connection or new request, this server raises an event. So we can use the on method to handle that event. So before listening, we want to register a listener or a handler. So server.on, the name of the event is connection that you can find in the documentation. So you don't have to memorize any of this stuff. Okay. And the second argument is a callback function or the actual listener. As you can see in the tooltip here, this listener is a function with one argument that is socket of type socket class, and it returns void. So here we have the arrow function syntax in ES6. So let's add an arrow function that takes a socket and goes to this code block. Now here we can simply log something on the console, new connection. Now back in the terminal, let's run this application. You can see we're listening on port 3000. Now back in the browser, let's head over to localhost port 3000. And now if you look in the terminal, you can see we have a new connection here. So you can see this server object raises different kinds of events that you can respond to. Now, in real-world applications, we are not going to respond to the connection event to build an HTTP service. This is very low level. So let's delete this. What we commonly do is we pass a callback function to this create server method. So function, this function takes two parameters, request and response. Or we can use the arrow function syntax. So we remove the function keyword and add this fat arrow here. Now in this function, instead of working with a socket, we can work with the actual request or response objects. So we can check if request.url equals /, then we can send something to the client. For example, response.write hello world. And then we end the response. Okay, now back in the terminal, we can exit here by pressing Ctrl and C and then run the application again. Okay, we're still listening on port 3000. Let's refresh this page. So we got hello world on the home page. Now, if you want to build a backend service for our web or mobile applications, we need to handle various routes here. For example, we can have another if block, if request.url equals /API/courses. Perhaps here we want to return the list of courses from the database. So we would do something like this, response.write. Now here we want to return an array of objects using JSON. So we use JSON.stringify and give it an array of objects. Now for simplicity here, we don't have to worry about the database or complex objects. Let's just return an array of numbers, 1, 2, and 3. So we pass this to JSON.stringify, which will convert this array into a string using JSON syntax, and then we'll write it to the response. And finally, response.end. Now, back in the terminal, we need to stop this process again and run it one more time. Now, in the future, I will show you how we can automate this, so every time we make a simple change to our application, we don't have to restart it. So now back in the browser, if we go to /API/courses, we get an array with 3 numbers. So as you see, building a web server with Node is very easy. Now in the real world, we are not going to use this HTTP module to build a backend service for our application. The reason for this is because, as you can see here, as we add more routes, this code gets more complex because we add all of them in a linear way inside this callback function. So instead, we use a framework called Express, which gives our application a clean structure to handle various routes. Internally, the Express framework is built on top of the HTTP module in Node.